Hello and welcome to my channel. I am the Mad Computer Scientist. On this channel I discuss math, computer science, and technology topics that are of interest to me. But before we begin with today's video, I would like you to do me a favor, especially if you are new to this channel. Be sure to hit that like button, be sure to hit that subscribe button, and if you subscribe, be sure to ring that notification bell. Thanks. Today we're going to discuss why this channel is called the Mad Computer Scientist. Now I do have a reason for this, and this video will be placed on the channel as the one people see when they first click on it. Now that we've gone through that, let's explain why this channel name is what it is. Computer science didn't start as a discipline until about the 1960s, perhaps a little earlier because we do consider Alan Turing the father of modern computer science. And then we have important figures like Ada Lovelace and Charles Babbage who lived in the century prior to Turing. We also have figures like Grace Murray Hopper, Dorothy Vaughan, and the women who programmed the ENIAC, who apparently are not usually named and should be in my memory but are not. The thing is, back when computer science was developing as a discipline, computers took up an entire room. They usually weren't connected. They were basically treated as big fancy calculators. Now, as the decades grew on, the capability of computers grew, and we saw things like relational databases arise in the 70s, along with newer programming languages, some of which, like the C programming language, still exist today. In this era, something would be born that today we call the Internet. Now, the Internet at first was just mostly a government and college toy. It didn't have the graphical capabilities that we know it has today, and it had limited application. Mostly, there wasn't a lot of programming done for it, and usually it was either apps for the mainframes or desktop apps once computers like Apple, Commodore, and the IBM personal computer came onto the market. Computer scientists and programmers generally had the attitude that if they could do something, they should. And the thing is, this really wasn't a problem because computer science had so little widespread impact at the time. At most, you were going to damage one computer and not an entire society. However, as computers became more interconnected, especially with the birth of the World Wide Web, and of course large services and even now AI applications, we're finding out that the computer science we're using affects larger groups of people. One of the earliest problems that people spotted was that Google and other search engines would essentially control what information people had access to. Another major problem came about when the algorithm started trying to choose what people would see based on what the algorithms thought they were interested in, and this included their political biases. It is this tendency that has led to increasing polarization. After all, most people, and I myself am guilty of this, do not go out and seek additional information from the other side on Twitter. Of course, not the problem. If you're on Twitter, you might believe the other side doesn't get anything right ever. Now, this is a mistake, but the problem is the way weak AI, as it's called, is used on social media sites leads to what is known as a filter bubble, and filter bubbles can lead to the creation of echo chambers. And if we get further and further into our own echo chambers without trying to find information from the opposing side, we never get the opposing viewpoint. This is why, to this day, I still listen to talk radio, even though talk radio has become relatively useless, with people yelling about things that don't matter, when they could be focusing on real political issues. Even worse, we know that the social media algorithms can be manipulated by foreign agents to sow discord and disharmony, as was done during the 2020 election. And before you say this wasn't done to my side, it was done to both sides. This is studied, it's well documented, it is not in question. But perhaps even worse than the problem with the content selection algorithms used by Google, Twitter, and Facebook is the problems we're creating with generative AI. some people have correctly referred to generative AI as a plagiarism-generating machine. This is because of the way generative AI works. Large language models, for example, are trained on a data set, and they spit out responses based on their training data set. While the training data set is not necessarily the entire internet, it is usually taken from a large section of the internet. And all the generative AI does is try to predict whatever the next word is going to be. That is why, even if generative AIs use correct information, they will often hallucinate and give you the wrong answer. Academia, as well as high schools, are still trying to figure out how to deal with this, and at the moment there is no good way of telling whether someone used generative AI or not, other than some clues like writing style and programming style that can be used to tell if someone used ChatGPT or a similar program. As bad as the plagiarism problem is for academia, artists, especially independent artists, have a different and valid complaint about generative AI, and that's how the programmers trained these programs. There were ways the programmers could have trained these programs that would not infringe on an artist's copyright. Unfortunately, they did not do that, and they just assumed that everything on the entire internet was released under public domain or something like the Creative Commons license, but they didn't read the bit where the Creative Commons license says you have to link back to the original artist. Now, could they have gotten around this? Yes. The programmers of programs like DALL-E could have gotten around this by training their programs only on art that the creators had specifically said was either open source, in the public domain, or licensed under something like Creative Commons. But they did not do that. And when the artists found ways to combat this, the programmers got annoyed, saying, "You are limiting our data sets," which, yes, that was the point of what the artists were doing, because the programmers were careless. They thought about whether or not they could do something and didn't think about whether or not they should. Now, as far as the legal implications of this go, I do not know how this will play out. Generative AI art still has to be tested in courts, and we have to see how the courts will rule on the copyright issues surrounding it. At the moment, the law is not clear, although I tend to side with the artist on this one, because generative AI is not generative in the human sense, it's just rehashing and doing mashups of work that already exists. Before anyone angrily goes to the comments, I know there are people who disagree with me about how this works, and perhaps my opinion will change if I study some more. But that is my opinion as it stands right now. And some people have also argued this is the way humans generate art, and they might be correct about that one as well. I could go on about a variety of problems, including the problem that exists with bias in training data sets. Now, it is not that the algorithms themselves are biased. They are not. They are just doing what they're designed to do based on the training data. However, the problem arises when we use training data that comes from any human source. Implicit and explicit biases will be found in those sources, and a lot of the work of companies like OpenAI is trying to correct these biases when they find them. Rather than ramble on and wish I had generated a script for this video, which I really should have done and need to start doing for videos like these, I think I will wrap it up. There is a reason why there is an emerging field of sociology called data justice that looks into the problems that artificial intelligence is causing in the world. In fact, if you want to start on it and want to deal more with the math end of the topic, I recommend you pick up a book called Weapons of Math Destruction by Cathy O'Neil. It is a fascinating and often humorous look at the way statistical models can be misused. Another interesting book that focuses on the trucking industry and how data collection is not necessarily a good idea for the worker is Data Driven by Kathy Levy, and I hope I got that name right. I will put Amazon links to the books I'm mentioning in the description below. And all of this, dear viewer, since we're coming to the end, is why I have called this channel The Mad Computer Scientist, because Computer scientists have been doing the Jurassic Park thing for decades. They're thinking about whether or not they could without stopping to ask whether or not they should. And it's time computer scientists start asking that question more often. Now go out and write some code.